So let's continue the program development. So we are taking the value of n. We are taking the value of n from the user. So how many terms to be added, asking the user. Right. Okay. Let's say 2. Let's say 5. That's it. So next we want to use a loop for int I equal to, let's say 1, I less than n, I plus plus. So we want to add first 5 terms, okay, as directed by the user. What is the role? What is the first job as per the problem statement? Write a C program to add n number of terms of the series to calculate Sn. Okay, let's do that first. So 5 times you have to run this for loop. Initially Sn equal to 0. Okay, so Sn equal to Sn plus the rth term. And what is the rth term? We have defined uh, the rth term is h to the power r minus 1 by r minus 1 factorial. Okay, so it is uh, power of x comma r. Let's say this is r r power of x comma r. So this is x to the power r, and then x divided by r factorial. So R in C language we do not have any function to calculate a factorial of an integer. So we have to define our own function which will calculate for us the factorial of a number. Okay. One thing here, uh, the value of R, the first term R is equal to 0, second term R is equal to 1, nth term R equal to n minus 1. So the value of R cannot be started with 0, 1, rather it will start from 0. Now it's fine. Okay. So now let us define a function which will calculate factorial. So here I want to check before this for loop whether I am able to calculate factorial of a number correctly or not. So before that, let us call a function that fact and display it. Okay, so this printed message should display a value of 120 because 5 factorial is 120. Yes, the value of 120 is coming. So this function is working good. So this function is able to calculate factorial of any number, a positive integer. Okay, so now let's activate this loop. So this code is fine. This syntax is working fine. Okay, so with the help of this for loop, SN stores the sum of first 5 terms. Okay, and let's display that number. Right. Powers. Okay. So we require to include maths.h. 2. Let's say 5. So S5 is equal to 7. Let's check what should be the S5. S5 C 6.999. So almost it is 7. So we are getting the correct answer. Let us check with other values of n. Let's say this is 7. 7 S7 equal to 7.3 uh, 5556. Let's tally with our hand calculation. S7 equal to this. So absolutely correct. So the program is working very fine. So it has done the first job. Write a C function as a program to add n terms of the series. Also, we have used a recursive function to calculate factorial of an integer. Now, after completion of this addition, calculate the absolute error for a given value of x and display it. So let's calculate the error. Absolute error is equal to, so let's absolute equal to the difference between, okay, so power of x comma 2, right? Sorry, e to the power x. Now what is e to the power x? Again we have to define e, the value of e up to 6 decimal place, 2.718281. 82. Okay, so this is, so you have defined a constant e. So power of e comma x e to the power x. This is e to the power x minus Sn. Okay, but this is not an absolute difference. So we want to use a function fabs. Fabs is inbuilt function defined inside math.h header library, which is supposed to calculate difference between absolute value of a floating point number. Okay, and only abs is supposed to find a magnitude or absolute value of integer data type. So that's the difference. So now we can display it. Printf Absolute error is equal to percentile f. Uh, so let's check. 2, 7. So 7, this is correct. Absolute error to 0.33501. See, 0.33501, which is almost equal to this 0.0335. Okay, so this is done, and calculation is done based on some rounding policies, and that's why that's is there. That's a slight difference between the practical result and the theoretical result. Okay, so everything is going very fine. We can also tally up to this with another uh, like 8. So 738095. Let's tally. So S8 equal to 0.7.380952. It is 53. It's fine. Absolute error equals 0.08104. 0.08104. That's absolutely correct. Okay, so fine. Everything is going fine. Now obtain the value of n after which error becomes less than equal to zero point 0.0. This is the last question to be answered. Okay, so what is the error we got? 0.008. Is it less 0.01? Yes, it is 0.0. So the question is, what is the number of terms a user can give so that error is well less than threshold error? So it's a trial and error process, right? But we want to write a program which will calculate for us minimum value of n required to achieve error less than threshold error, right? So this program is so far is not able to give us that information. What should be the minimum value of n? User is providing the value of n. The program now should be adaptive so that it can produce the required value of n. User may not know the value of n when for which the error becomes less than threshold. Okay, that's the question. So uh, let us calculate this error every times. What we are doing here, we are calculating the absolute error every time inside the for loop. Means we are doing this every time we are calculating Sn. In parallel, we are calculating also the absolute error using the for loop. Now checking here if the absolute error is less than or equal to threshold error. Okay, threshold error. Then printf becomes convergent with percentile d terms. Expression Sn equal to percentile f and absolute error is equal to percentile f. Okay, first we are n, no, this is r plus 1. R plus 1 gives us the number of terms. Okay, when this condition is achieved, and then Sn is simply Sn, and then absolute error. This can be %. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. Okay, so this is, and then we want to discontinue from here. What if this condition is not achieved? Else, if this condition is not achieved, then this for loop will keep going on. Okay, that's fine. So let's try to validate this. Two, how many terms? Let's say four. Okay, if right, let's say four. The series is not convergent with five terms. How many terms we want to add it? Okay, it should be it is r plus 1, it should be r, right. So series is not convergent with 4 terms, and s4 is equal to 6.63. S4 equal to, the answer is correct. Also absolute error equal to, where it is 1.055724. Sn is correct, so you have to add 4 terms. Error is 6.33. Let me check. Oh, my hand calculation is somewhere wrong. It should be 0.055724. Okay, that's correct. So everything is going fine. Now, let's say 15. What is the advantage of doing that, modifying the program? Let's randomly, with the trial and error process, user is providing 15. See, series become convergent with 8 terms. S8 equal to 7.38, this absolute error equal to this. What happened? Even if the user has provided the value of n to be 15, but this program is not iterating for the entire 15 terms. It is only calculating sum of first 8 terms, because after 8 terms the series becomes convergent. This condition is already achieved, so it is not at all required to add ninth term, 10th term, and so on up to 15th. That is the utility of this program. But still, this program is not giving us the minimum required value of n. So let's, yes, it has already given us. How? See, so 2, let's say 100. Okay, series becomes convergent with 8 terms. So that's the answer. Okay, so this means when the series will become convergent, so when the error becomes less than the threshold error, we call the series becomes convergent. So how many terms with which it becomes convergent? The answer is 8. Okay, so that's the answer we got. Okay, so slide so this program is to be modified for these cases. Let's say 3. This is not convergent with 3 terms. So what is the number of terms to be is required to make it convergent. In this case, the program is not able to give us that information. So let's try to do that. So if with n equal to 3, this for loop is terminated, and this due to this if condition true, we got this message. Okay, so what we have to do here, this is fine. So let us try to find out this. So this for loop should be repeated again. Right. So since so for r equal to here it is, should not be y. Do Hn equal to Hn power this, absolute value equal to this if break while this condition. That's it. Okay. Now 2, now 3. Series is not convergent with 3 terms. Okay, let me. Right. Series is not convergent with 3 terms. S3 equal to this and this. But after this do while loop, it has produced an information. Series will become convergent with 8 terms. So says it equal to this, absolutely. So initially, user has provided a value of n equal to 3. Certainly for n equal to 3, series will not become convergent. Okay, so that information is given. Then the program calculates the minimum value of n for which the series will become convergent. So both are things. So I hope all of you have understood. So if you have any query, you can put a query in the Moodle or ask in the group. Thank you.